Hi everyone, welcome back to day 2 of live course today with Thomas Bautic. I'm Nurul Ishak with O'Reilly Media and I will be a facilitator today. Now a quick reminder, we are recording today's session and we will have it within 24 to 48 hours. You will receive an email as soon as it is available. Now during the course, you can complete our feedback survey at any time. It is accessible by clicking more in the top right corner of your screen. Or it will open automatically when we finish today's session. So please take a moment to fill it out and share your thoughts with us. All right, I'll pass the floor over to Thomas to get started. Hi, Thomas.
Hello, Nurul, and thanks. Warm welcome from me as well. Let's just get started because we have even more on agenda today than we had yesterday. We will probably not manage all of it, but you have more slides to fill the gaps. So let's start. The first topic for today are Snowpipes. And Snowpipe related to yesterday, if you remember, we talked about the copy command. The copy command is used for, let's say, batch-oriented ingestion. It's something what you need to schedule, and it runs on schedule. On the other hand, Snowpipe works in near real time, and basically every time there is a new file available in the cloud storage, there is a send a notification towards Snowflake, and that notification will trigger the ingestion on Snowflake side. So it's some kind of automated data loading feature. As you can see on the drawing, we might have different sources like some IoT devices, log files. It can be even relational databases. It doesn't matter. All of them send files to cloud storage. Once the file is available here, there is an even notification towards Snowflake, and that notification triggers the ingestion. Another difference compared to copy command is that the Snowpipe is a serverless feature inside Snowflake, meaning that you don't need to provide a custom or user-based virtual warehouse where the Snowpipe runs. There is a system warehouse called Snowpipe, and Snowflake basically scale it up or down basically on your needs. So you don't need to manage it at all. It still offers per second billing. So it, from cost perspective, it works pretty similar. Recently, Snowflake has rolled out the update of the pricing for the Snowpipes. I'm not sure if it's already rolled out for all the customers and all the regions, or it's like continuously rolled out. But the change is related to the pricing. So now you are just charged per transferred terabyte of data. So there is no charge for runtime of the virtual warehouses, but it's purely on transferred data amount, which is nice because I did some comparison, and it's much more cost effective with the new cost model in the sense that it's cheaper. It's still file-based or batch-oriented, so you still need to have files as a source. And yeah, if you would like to see the consumption, you can see it under Snowpipe Warehouse. What might be the use cases? Yeah, you can think about the Snowpipe in the same use cases where you would use copy command. The difference here is that you don't need to schedule it, so and data are available in near real time. So whenever there is a new file available in the cloud storage, it's immediately ingested. The latency is between 1 or 2 minutes, so it takes some time to send the notification and then trigger the ingestion on Snowflake side. So it's not something what would be available within 5 seconds in Snowflake, but within a minute or two, you have your data in Snowflake table. Yeah. You can import some data stream from IoT devices or data lakes import. So some summary here. What is the Snowpipe? Snowpipe, we continuously ingest data into Snowflake in near real time. It's ingestion automation. We don't need no manual copy commands. We don't need any scheduler for it, either internal or external. Snowpipe has the same support in in sense of the file formats, so it also supports semi-structured data. It's a serverless feature, so you don't need to manage any virtual warehouses for it. And it still offers per second billing, even though there is a change now. So it's charged per transferred terabyte of data. It means that there is basically zero management you have to do around it. We have two types of Snowpipes. What I just described, you have the files in cloud storage, and there is an even notification which triggers the ingestion. That's Snowpipe called auto ingest. Another Snowpipe I will be talking about right now is called REST API. It works slightly different because there is no notification, but there is a Snowpipe REST API endpoint. And what you need to do, you basically pass a list of the files which you want to ingest into the Snowflake to that REST API endpoint. So you pass the list of the files which you have available inside the external stage or internal stage. Yeah, the REST API works for both internal and external stages. The other auto ingest Snowpipe works only for external stages. So what you need to prepare if you want to use the REST API Snowpipe, it's the similar for the other one as well. You need to have a stage, you need to create a pipe, you need to do some security configuration. In terms of security configuration, we talked about that yesterday. You need to have that storage integration, but for API, we also need to have the token, which is part of the payload. Snowpipe and this one, REST API based, use a key pair authentication for the user, and you also need to have proper privileges on the database where you want to store the data. Of course, the best practice is just to create a separate user which will handle all of that and not reuse your own user or something what you use for something else. Once you have all the preparation, you can call the endpoint, which is called insert files. What are the other endpoints? So we have that one where we insert the files. It's the post one. Here you can find the URL. So at the beginning, there is your account identifier, and REST is then same for everyone. Here you need to pass your pipe name, insert files, and you can add some request ID. This is your custom ID, which can help you to bundle together the files which have been ingested together. Then you have two more endpoints for receiving some metadata related to the ingestion. One is called insert report, and another one is load history scan. They work in similar way, but the differences are that the insert report is limited to recent 10,000 events, and the events are retained for maximally 10 minutes. The other one doesn't have this limitation, so it can still return up to 10,000 items, but it's not only for last 10 minutes, but it can return the data between 2 points in time in the past. So it depends if you need to fetch something right now once you ingest the files, or you need to retrieve something from the history. Before I will start about the auto ingest, so the other one, the REST API, is something what you will probably use for some application development or app development in general, not something what would you use for importing data into data warehouse, because then it's much better to use this auto ingest one. Yeah, so it works differently. As I said, you will receive a notification from the cloud provider, and that notification triggers the processing. Yeah, this is also quite important, even for the certification. The difference is auto ingest supports only external stages. The REST API supports both internal and external stages. Cross-cloud support. Yeah, if you are on AWS, then you are fine and you can ingest data from whatever is, meaning that AWS hosted Snowflake account supports also storages from other cloud providers to ingest data into. But if you are hosted on other cloud platforms, you can ingest data through Snowpipe only from their own cloud storage. Yeah, so here we have a simple schema how the processing works. We have a data files which continuously flows into S3. There we have that event notification, which is the SQS event notification, which is sent towards Snowflake. Once it's received, the pipe kick in and start ingesting data. Here we have a DDL for Snowpipe. You can see that it's quite simple one, and basically we still have inside the copy command. So it's the same one you know from yesterday. We just define where to store the data, what is the location, what's the file format. And here we also define the type of the pipe. In terms of creation of Snowpipe, so we saw the DDL on the previous slide, but that's the one part of the configuration. It also requires to configure some things on the cloud provider side. Yeah, so either you have all the needed privileges or you need to cooperate with your cloud admins to finish the configuration. Because, of course, that's the part of the storage integration object. You need to have some permissions to access the bucket. The best thing to do right now is to use the role-based access, so you would have some IAM role for Snowflake, and you also need to configure that SQS notification for that S3 bucket, which will be sending the notification towards Snowflake. On Snowflake side, so as I said, you need a storage integration with all the privileges. Here we have another schema where it is visible how it works. So on the one end, we have a Snowflake where we have external stage. We have that storage integration. On the other hand, we have AWS with S3 bucket and files and the IAM user which is used by Snowflake to authenticate. Yeah, some details about SQS setup. So once you create a pipe, you will run show pipes command inside Snowflake, and in the output you can find one of the columns which is saying notification channel, and that notification channel is the SQSQ created by Snowflake and assign it to your pipe to Snowflake. So you just need to take that ID and configure it on S3 side as a target for the SQS notification. I can see a question saying, can they be set up if there are any changes in other databases like Oracle? This is not a CDC, which would be like monitoring the source databases. So it can't be done for monitoring changes in Oracle or other databases. To do a proper CDC, you need to use something else. Snowflake has their own tool for it, OpenFlow, or you need to use some other tools which can do the CDC. So this is still file-based, so it just monitor external storages and ingest the data from files, not from databases directly. Yeah, so a few more details about the configuration, what needs to be enabled for the SQS notification. So all events, and send it towards SQSQ. And we will have a look on it in the exercise. So what we'll try to ingest some data into Snowflake through Snowpipe. I will also show you the needed configuration on AWS end, so you can see it, how it fits together. Don't worry if you are not familiar with like the cloud part and how to do all of those steps. Everything is quite well described in Snowflake documentation. Yeah, including the code. So what you need to do is just to copy, paste the provided code and replace the IDs with your own IDs, and it should work if you are just starting with that and want to try it on your own. Let me share my screen and we will go through it. Okay, so I am inside my Snowflake account again. So what we need is also the storage integration, which we already have in place from yesterday. So it's the external stage, it's S3 as a provider, it's enabled. Here is my role on AWS side. I will show you that role. And here are allowed locations. So with that storage integration, I can access following bucket. Once you have a storage integration, you need to finish the integration between Snowflake and AWS. So what you need to do is describe the integration, and in the output, you will find those two values, which you need to provide on AWS side when you define the trust relationship between AWS and the other party, which is Snowflake in this case. I will show you again where it is done. Then we need a stage. So let's create a new one and call it Snowpipe stage. I have a separate directory for my Snowpipe files, and we just pass the storage integration. The reason why I'm doing it now, it's that this bucket is not public anymore, so it's protected by some under my account. So I need to have a role to access it. Yeah? Let's create a stage. And now we can verify if the authentication works. So I can try to list what is inside the stage. And there is one file, which is completely fine. The most important now is that I can connect there and authentication works. Let's create also the landing table. So that will be a table for our Snowpipe. It's quite simple with few columns. And last but not least, let's create also the Snowpipe now. So that will be the last part we need to do on the Snowflake side. So it is the auto ingest one. We will copy data into our newly created landing table from this stage. And the file format definition is included here. Pipe is recreated. Once we have it, we can run show pipes. And as I said, one of the columns here is notification channel. And basically that's the SQS channel Snowflake has created for our pipe and assign it to it. So that's something what we need to copy and pass it to AWS. I will switch the windows into my AWS account now, and let's start in the identity and access management console. So as I said, we need some role, and first we need some policy. Inside the policy, we will say what the role will be allowed to do. So I called my policy a Snowflake access, and I can show you, sorry, no, it's here. What I have there, so it's just this access for S3, and it's limited to following buckets. Yeah. Again, this is something where you need to write on your own, but you can copy it from Snowflake documentation. So we define a policy, and then we will define a role and assign that policy to the role. So I have my Snowflake role here. Here is the ID, and if you remember, that's the ID I passed to my storage integration here. I just attached that policy to my role. And the last thing which I need to define is that trust relationship between Snowflake and AWS. So again, this is the code you can get out from Snowflake documentation. And those two values, I have multiple here because it's used for more stuff. But those two values is something what you get out from describing that storage integration. Yeah? And that's all what you need to do for authentication between Snowflake and AWS. That's one part. What we also need to configure now is the event notification on S3 side. So let's go into S3. Fine, just this one. In the properties, something in the middle of the page, notifications. I already have that Snowpipe ingest, so let's edit it. You can add some prefixes if you want to limit it. Let's tick all the object create events, and in the bottom of the screen you specify the target. That SQSQ we got out from describing the pipe on Snowflake end. That's all. Now the configuration should be finished. Let's try to upload some files into the bucket. And once the file is there, I will delete that one first. Once the file will be there, it should trigger the whole processing, basically. The SQS notification will be sent. Let's add files. I have it somewhere. Okay, now file is there. We can go back. And let's see. And the table should be empty. Yeah? So as I said, the latency is between 1 or 2 minutes. So now I uploaded the file, notification is being sent towards Snowflake, and Snowflake will trigger the pipe. You can check the status of the pipe with using this system function, system pipe status, and you will pass the name of your pipe inside, and there you can see what is the status. So it's currently running, and you can see there are no pending files, plus some more metadata related to that pipe. You can see that last forwarded file path is that file we just uploaded. So that is the last one, and that's the one which is currently being processed. So let's try to query that table again. And now it has been ingested. So that's the content of the file we uploaded into S3. You can check the count. It's 1,000 records. It's correct. So that was Snowpipe and how it works. And we can move on to next topic, which is related to query profiles. So what is it? Yeah, there is plenty of the questions related to Snowpipe, so I will try to answer them in the meantime. Let's just answer another one live. The notification sent to Snowflake, is it visible to a user? Any specific role required? No, you can't see it. It's something what works behind the scenes. Not sure if it could be visible on AWS side, somewhere in the CloudWatch that the notification has been sent, but you can't see it inside Snowflake. So query plan, query profile, what is it? That's something what you will use when you need to understand the performance of your queries. And it's a DAG consisting of operators connected by links. So what is the DAG? DAG is direct acyclic graph consisting of multiple nodes, let's say. The operators are things which process set of rows. So it can be table scan, it can be aggregation, it can be sort, it can be join. Then we have, here we have a list of some of them. And then links. Links are basically exchanging the data between the operators. So how data moves from one operator to another one. They also handle the parallel redistribution of the data at the runtime, because multiple nodes can run at the same time. And in the query plan, you will also get some detailed statistics which are related to whole query, but also to individual operators. Yeah, as I said, query plan should be your entry point when you need to do something related to query optimizations, because it helps you understand how the optimizer prepared the query plan and how it runs. So it can help you identify some bottlenecks and spot some typical mistakes related to SQL query execution. How you can access it, the query plan, there are multiple ways. Either you will go into the query history in Snowsite, and then for every individual query, you have a button or link there, open the query plan. Or if you want to access the query plan for the currently run query or the query which you just run, just in the worksheet, in the bottom, you have the output of the query, and one of the options there is open the query plan. You can also get it programmatically, so there is a system function called get query operator stats. You just pass the query ID into it, and you will get basically the same thing which you can see graphically in the query plan. You will get it as a JSON, so if you want to process it somehow programmatically, you can do it that way. Let's have a look how it's mapped to the operators. So what we are running here is quite simple query where we aggregate the data from the orders table with some filter. So yeah, so we are selecting data from orders where the year order date is greater than 1994, and we just calculate number of the orders and sum of the total price. And this part is then part of the query plan. So as you can see on the bottom, we have a table scan. So we are retrieving the data from the micropartitions from the files. So that's the from part of the query, yeah, the table scan. Once the data are retrieved, what we do, we filter it out, which is the where part. Once the data are filtered, we aggregate them. So this is this part in the select. So what we do. And last part, once the data are aggregated, we sort them. So this is the order by here. Those lines between are the links connecting the operators, and you can see the numbers here. This is the number of records which flows from one operator to another one. So you can see that we selected at the beginning more than 81 million records. And after the aggregation, we have just 4. How to identify the query pruning performance. We saw that yesterday. So this is the statistic pane. In the bottom, you have 2 attributes, total number of the micropartitions and number of the scanned micropartitions, which is the same in this case, almost 300, which means that we did a full table scan. There is no partition pruning at all. So what we can do, we can try to add some data knowledge to do some micropartition pruning. So what we can do, let's try to add another condition. In this case, it will be an order date, because most probably we don't need to scan the full order history, but we are interested about some limited period of time. So like in this case, we added that. And if you check it now, we just scanned only 30% of the micropartition, so 123 out of 300. So that's quite good pruning. And it also means that the data internally are organized along that order. Do you know what else we can improve? We can see that the query now took 15 seconds. We have quite nice pruning. What else we can do? If you have a look on the select part here, what we do, we select all the columns out of the table, meaning that there is no column level pruning. So most probably we don't need all the columns which are there. That will be the fact table with plenty of IDs. Maybe we need only some of them. So what we can do, let's add some columns which we really need. We just selected 3 of them. There is no change in number of those scanned micropartitions. If you remember from yesterday, every micropartition always contained the whole row. But the query is still 5 times faster because now it took only 3 seconds. Yeah, and that's because we did column level pruning and select only a few columns. So please have that in mind and try to avoid doing select star from really large tables and add only relevant columns and the columns which you need. Let's have a look on some other performance issues and how the query profile or query plan, you can see both names, query profile or query plan, can help you to identify them. So data spelling is another quite usual performance issue. So what is it, data spelling? Data spelling means that the virtual warehouse which you are using for running your queries the data to process. So once it's running out of the memory, it will start spilling the data into the local storage. That's the SSD inside the virtual warehouse. Once it's running out of space inside that virtual warehouse, it will start spilling the data into the remote storage. And the remote spilling is something what really kills your performance because then you have a network communication included into that and data are transferred over network somewhere. So once you see some queries which are running for a long time, most probably it will be because of the data spilling, so you don't have enough memory. Yeah, in terms of root causes, it can be like quite challenging to find all of them because it can be caused by multiple things. But let's have a look on how to identify such issues in query profile, or if you want to check some old queries, how you can do it. So again, you will open the query profile, and now you need to find just another item in the statistics, and it's called bytes spilled to local storage or bytes spilled to remote storage. So there you can see how much data have been written into either local storage or external storage. So what we are doing here, we are just copying data into a landing table with the copy command. And you can see that we have only the local storage spilling here. It's not so bad. It's just, but still it means that you didn't have enough memory or CPU power when it ran. That's why some of the data has been stored into a local disk. Let's have a look on some of the root causes. You might be in the situation that you are processing a lot of data, let's say billion of records, and you are trying to do it on the extra small warehouse. That might be like relevant because you have like so huge amount of data. And if you remember from yesterday, the extra small one warehouse has just 16 gigabytes of memory. So it's not enough to process large amounts. So you can think about changing that. Or you might have some concurrency issues. So every warehouse can run by default 8 queries in parallel. So if you have like multiple queries running at the same time, then of course all the resources available in that virtual warehouse are shared across all those queries. Or you might be doing some like heavy processing if you are processing a lot of data and you are doing some, let's say, window functions there, a lot of CTEs where you have a lot of intermediate results, or you are doing some memory intensive operations like aggregation, sorting, and this kind of stuff can also cause that not everything can fit into memory. Yeah, sorting, recursive CTEs, large joins, large aggregations, window functions. So how you can solve it? The easiest, as always, increase the warehouse size because then you will immediately get more memory. And it can be like relevant fix especially if you are really using extra small warehouse and trying to process a lot of data. But if you are already on, let's say, extra large one or even larger, and you are still facing some kind of data spilling issues, maybe it can be a time to think about other possible solutions. So what you can try, reduce concurrency. If there are multiple queries running at the same time, try to limit that. How you can do it, you can split the workload between multiple warehouses, or you can try to configure multi-cluster warehouse, which can handle the concurrency issues. You can improve pruning by auto-clustering. Intelligent data ingestion is something which is also related to the clustering. We will talk about that later today. What also every time works is simplify the query logic. So you can review your query and try to find if there are any places which you can simplify, or if you can split the processing into multiple steps. So maybe you can do the processing in some phases, store the intermediate results into some temporary table, and then do another part. Everything can help. That was all related query plan. And again, a few questions for you. So please try to answer them and we will check the right answers. Let's have a look. So what are operators? And operators process set of rows. So not exchanging the data, but they are processing the rows. So operators are those: table scan, filters, joins, sorters. How you can identify full table scan in query plan? Okay, let's have a look. And yes, the correct answer is that all micropartitions are scanned. So you can check the statistics, you will see what is the total amount of the micropartitions, and you can compare it with scanned micropartitions. What is the data spilling? Let's check. And yes, data spilling means that you don't have enough memory to process the request. Perfect. So majority was right. And we can move into Snowflake caches, which is also related to, let's say, performance tuning, because a proper understanding of the caches can help you improve the performance of the queries and also reduce the costs. Yeah, I'm speaking about caches because there is a multiple caches in Snowflake, not the only one. And they have a different functions. They live in different architecture layer, and you can use it differently, or you would use them for different things. So let's have a look on all of them right now. So first one is metadata cache. I've already been speaking about that one yesterday. So inside the metadata cache, you have all the definitions, like object definitions. You have all those database statistics or micropartition statistics and metadata which Snowflake collects. Metadata cache is part of the cloud service layer, so it's stored there and processed there. Then we have another type of cache where we have multiple names. You can read something what is called local cache or SSD cache or a virtual warehouse cache. All of those names means the same, and basically it's the cache for a particular virtual warehouse. So there are stored the raw data from the tables, so not aggregated, not processed, but the raw data. And they are stored on that hard drive, which is attached to the virtual warehouse. There is no way how you can influence size of that cache. So the size is determined by the virtual warehouse size. Once you suspend the virtual warehouse, the cache is destroyed. So all the data which you stored there or have been stored there are like removed. The local cache means that only the partial data can be used. So when you will run some similar query which use just a portion of the data which is already cached inside that local cache, it can be fetched from that local cache, and the rest what is missing can be fetched remotely. Last type of the cache is then query result cache, and this one stored exact results from the queries. So once you run some query, the result is stored in that result cache. It's stored there for 24 hours. If you run the same query, exact same query during those 24 hours, the result will be retrieved from that query result cache and not calculated again. Of course, there are some conditions which needs to be met, like the underlying data cannot change in that time. There are also some functions which you can't use in your query in order to be stored. The results can be stored in that query result cache only in case you don't use some functions like current timestamp, for instance, or all the non-deterministic functions. So why? Because every time you run current timestamp, it will provide a different value. Yeah, so it can't be stored in the query result cache. This can be used by different users, but they need to use the same row. Let's have a look on more details about each one of them. So when the metadata cache will be used. As I said yesterday, some of the queries are pure metadata operations, like show commands, if you query for count, min, max values. So all these types of queries retrieve the results from metadata cache because they are stored there. The engine doesn't have to calculate them on the fly. It also means that for these types of queries, you don't need to have any virtual warehouse running or attached to the session because it's retrieved from metadata. You don't need to do anything to use that metadata cache. It's used automatically by Optimizer. As we already said, metadata are stored in cloud service layer, and a lot of metadata related to micropartitions are used also during the query plan phase. How to use a local cache, so the other one. So here the data are stored directly on the SSD of the virtual warehouse. The raw data are stored there, not the results. So when you run a similar query, Snowflake can use as much of the data as possible, which is already stored there. The local cache is available to all the queries which are running on the same warehouse, so it doesn't matter what's the role, what's the user, but it just needs to run on the same warehouse. And the optimizer always tries to first fetch the data from that local cache, and if something is missing, then it fetch it from remote cloud storage. So how you can influence usage of the local cache? So some of the best practices, what you can do. If you will group similar queries to be run on the same warehouse, then there is a bigger chance that those similar queries are using same data or similar data. And if you store the data once in the virtual warehouse cache, it can be reused by other. You can also have influence on the data suspension time, because if you suspend the warehouse too early, it would mean that the cache is destroyed. So there are different use cases when it makes sense to suspend the warehouse immediately once the operation is done. Let's say typically you are running some transformation pipeline. Once the transformation is done, you can suspend the warehouse because you are done with the work and nothing else will probably use the same data in a couple of minutes, let's say. On the other hand, if you have a warehouse which is attached to some reporting application or dashboarding application like Tableau, Click, Looker, there the use case is slightly different. Yeah, so how the users works there. They open the dashboard, take some time to calculate the data and fetch everything. Once it's fetched, the users are like looking on the charts, thinking about it, analyzing it, and it can take couple of minutes, right? After that, maybe they need to do some drill down or apply some filter. So they will go and apply the filter. If you would, let's say, suspend the warehouse in the meantime, it means that you would destroy the local cache and all the data which have been fetched and stored in that local cache will be destroyed. And once the user applied the filter, everything needs to be fetched again from that remote storage. So it makes sense for virtual warehouses which are used inside applications like Tableau or Click to configure the auto suspend to be higher than those 60 seconds. So you can go for 5 minutes, let's say. And the last one is query result cache, where we have the exact results. So when identical query run again, it's retrieved from that query result cache. You can find it in the query plan. So when you open the query plan, and you will see just a single note there saying it has been retrieved from query result cache, then you know it's coming from there. You can also see it based on the runtime, because if the query usually takes a couple of seconds, but from the query result cache, you have the result in milliseconds almost immediately. Yeah. What are the conditions? As I said, the underlying data cannot change in the meantime. That's one important condition. Another one, that the query does not use functions which are not deterministic, like the current timestamp, for instance. The results are stored there for 24 hours. So you need to run the exact same query during 24 hours. If you do that, then the clock reset and the data are still available there. And that can last up to 31 days. So you can have the data stored there for 1 month. What would be some use cases for it? Again, we can use dashboards as a use case. And you have some static filters or static dashboards and dashboard filters. Yeah, some which shows the same data without any time filters. Then it can be retrieved from query result cache. Same for the filters. Yeah, the filters are probably static. You have a list of, I don't know, your branches, list of sales agents, list of something. So during the session when you are working with the dashboard, most probably the query will be the same, so it can be retrieved from query result cache. Here we have a visualization of the query lifecycle, so how it works. So you submit some query and what the optimizer does behind the scenes. So first it will ask if the query is in query result cache. If yes, then it will ask again, okay, what about the underlying data? Are they same? If yes, it will retrieve the results to you. If the result is not in query result cache, then it's asking again, is it metadata related? If yes, let's get it out from metadata. If no, it will go and do the pruning and filtering, start the warehouse, start fetching the data, or if the warehouse is already up and running, it will check if there is something in the local cache, and then execute the query, return the results to you. And if all the conditions are met, maybe it will store the result into query result cache. So next time you run something similar, it can be retrieved from there. So here we have some summary related to different types of caches. So we have metadata cache, query result cache, and data cache or local SSD cache. Where it's stored, those two are stored in cloud service layer. This one is stored on SSD of the virtual warehouse. What kind of data are stored there? Metadata for metadata cache, query results for query result cache, and raw data for the local cache. When it's used, metadata cache is used automatically by the optimizer whenever it's metadata related operation. Query result cache is used when you run typical identical query. And the last one is used when the query you are running use at least partially some of the data which are already stored in cache. In terms of time, metadata cache is continuously updated. Query result cache results are stored for 24 hours. And the last one, the local one, the data are there until the warehouse is up and running. Who can use it? Metadata cache is available to everyone. Query result cache is available to anyone who have select permission on all the tables used in that query. And the local cache is available to anyone who can use the same warehouse, so no matter of the role or user. Again, few questions related to caching for you. Let's have a look. What is not a Snowflake cache? Yes, cloud service layer is not a Snowflake cache, but it's a storage for some of the caches. Which one resets after 24 hours? Let's see. Yes, query result cache is the right answer. And which one keeps the underlying raw data? Well, let's see. And yes, SSD cache is the correct one. Perfect. Let's take one more before we will have a break, and then we will take a 5-minute break. So virtual warehouse scaling. Yeah, that's the number one question I hear many times. How do I find out that the warehouse size is the right for me? Yeah, I would say that's $1 million question. What I would recommend is you need to experiment. So there is no like rule of thumb which would say you need to use this size for this type of queries, but you need to find some let's say typical queries for your use case, and then experiment with different size. Always start with the smallest one and scale up until you meet your SLAs. What can be used as a, let's say, rule of thumb in terms of fully utilizing the power the virtual warehouse has is that once you run some query, let's say on the extra small one, and it takes 1 minute, so when you scale up to small one, it needs to take 30 seconds and less, so half of the time, because the number of the resources is doubled. Yeah, so if it doesn't take half of the time and less, it means that you are not fully utilizing the warehouse anymore. But it still can be okay for you because it doesn't meet your SLA. So maybe you need to go even higher. But this is just a rule of thumb in terms of utilizing the available hardware and getting the most out of your spendings. You should always try to keep the warehouse fully loaded. So yeah, that can be different. That can have different implications, because yesterday we talked about the data ingestion. So here you can see the extra small one with 8 cores or threads if you want, which can load up to 8 files in the parallel. Same, it goes with running the queries. So the extra small one can run up to 8 queries in the parallel. Of course, it depends on the complexity of the queries. So if you will try to run really complex queries, I mean 8 of them at the same time, then most probably the warehouse will be overloaded. Yeah. The queuing. Yeah, if there is no enough power to run one more query, you will see some queuing on the warehouse. It means that some queries are waiting for some free and available resources to kick in. That might be okay if this is a warehouse used for time to do the ingestion, or the warehouse which is used for data transformation. Again, it might be okay to have some light queuing. But if it is a warehouse which is used by end users, and you can see there is a lot of queued queries, then it's probably a good sign to do something, either to split the workload into multiple warehouses or change the configuration of it. What are the other parameters it's worth to know when you prepare the warehouses? I mean, when you create them. One of them is the query timeouts. So you can configure the timeout, automatic timeout for the queries, which means what is the amount of time the query needs to run in order to be automatically killed. If you don't change it, the default value is 2 days, which is quite dangerous, because it means that you might have a user who will submit some wrong query, and if no one notices, it can be running up to 2 days and consuming credits, of course. So it should be under your radar, and you should change the timeouts every time you create a new warehouse. So you can do the configuration on different levels. You can configure one query timeout for your whole account, or you can do it on the session level, you can do it on the user level, and of course you can do it on the warehouse level. So most probably the best is to do it on the warehouse level, because you will have a different needs for different warehouses. What I always do that warehouses which are, let's say, end user facing and used by end user, I use really short period of time as timeout. Maximum for me is 1 hour because it's even more than enough, and users are not so patient to wait 1 hour to run some query. So feel free to go even with a smaller value. Then of course, for warehouses which are used by some systems for like data transformation, it can be higher, but still I go with 1 hour. If it's not enough to do the job, then I think more about like either increasing the size or trying to optimize it than having something what needs to be there running for, I don't know, 3 or 4 hours. So what's the parameter? It's called statement timeout in seconds. Again, it's worth to know it for certification. Can be asked about that. Multi-cluster warehouse. That's also something what I've mentioned, I believe already. Multi-cluster warehouse means that you will start scaling the warehouse wide into the wide. Yeah. So you are not scaling the warehouse up or down, changing the size of the individual warehouse, but you are adding multiple clusters into the same multi-cluster warehouse. Here on the drawing, we have a multi-cluster warehouse which has a single 6 nodes. So each this node is individual virtual warehouse. So if we would suppose this is the extra small multi-cluster warehouse, each this node has 8 cores, 16 megabytes of memory, yeah, and some hard drive. So you have 6 of them bundled into the single multi-cluster warehouse. When you define multi-cluster warehouse, there are a lot of other options which you can now use. The basic properties are min and max count for the cluster inside. In this case, we configured min and max for 6. And then there are some properties which are related to allocation of the resources inside the multi-cluster warehouse, because you can do the allocation statically or dynamically. And it's controlled by something what's called scaling modes and scaling policies. Yeah, good question. How the multi-cluster warehouse impact the cost? I would say significantly, because here you can see we have 6 nodes. If it will be extra small one, so one costs 1 credit, but this one will cost you 6 credits. So you will be charged for every node inside based on the size. So how to allocate the resources inside? I believe, yeah, I have a slide on that. Let's see. So when to use multi-cluster warehouses. So multi-cluster warehouse is something what you will use for solving the concurrency issues, because the queries are then distributed inside the nodes. I mean, they are distributed to different nodes inside the multi-cluster warehouse, but the one individual query will always run on single node, not on multiple one of them. But let's say a typical use case, you know that you have every Monday morning, there is a board, 20 users who need to open one dashboard to check the sales over the weekend. So you know that every Monday at 9 a.m., there will be 20 people running some queries. So that's the typical use case for the multi-cluster warehouse, because you can't handle 20 queries on the single warehouse. So you will define multi-cluster warehouse with maybe 2 or 3 nodes inside. Yeah, so let's have a look on those modes. First mode is called maximized. It's the static control of the compute resources. So you will use maximized scaling mode when you define same amount or same number for min cluster count and max cluster count properties. So that was something what we saw on the previous slide. We had a 6. So that multi-cluster warehouse used maximized mode. It means that whenever you spin up such warehouse, it will start with all the nodes up and running. So all those 6 nodes will be started at the same time and be operating, and you will be charged for them. And that's the typical use case for the scenario I described. So every Monday morning, you have those 20 people running the queries. So it's predictable how many people will be or how many queries will be running there and for how long. So there you can configure some multi-cluster warehouse with 3 nodes, because 3 nodes will be okay, and you know that it's needed for maybe 30 minutes. So it's like predictable. And those numbers are static and not fluctuate over the time often. But then you might have a different use cases where you don't know how many queries will be running there, how many nodes you will need, and for how long. So then you can use second mode, which is called autoscale, where you assign the resources to multi-cluster warehouse dynamically. So once you assign different values for main cluster count and max cluster count properties, it means that you are using autoscaling mode. And here, the clusters are started or suspended based on load. So we have 2 strategies, how the clusters are added into multi-cluster warehouse, and it's called scaling policy. So this is something what you would use where the load fluctuates over time. Yeah, so you don't know how many queries will be there and for how long you will need such big power. So what are the scaling policies? We have 2 of them, standard scaling policy and economy scaling policy. Standard means that the new cluster is started as soon as there is some queries in the queue. So it has that implication that new cluster is added into the multi-cluster warehouse until you reach the max cluster count value. When the clusters are removed, so I have this drawing, which can be maybe easier to understand it. So what the multi-cluster warehouse does, there are some checks done every minute when the clusters are removed. Yeah, so we have like 3 nodes or 3 clusters inside now, and what's happening every minute? The cluster is trying to check if the load, which is done on the least busy node, let's say it will be this cluster number 3, can be redistributed to other 2 nodes. Yeah, so let's say they are running 2 queries still. So it's asking, can I take those 2 queries and put it here or here? If the answer is yes, then perfect. Is it still case? Is it still the case? I can move the 2 queries which are here to other clusters. Yes, and it will do one more check after 1 minute, and if the answer is still yes, it will remove this cluster and redistribute the running queries to other 2 nodes. If the answer is no in any phase, it will basically return the check at the beginning and it start over. And this is happening behind the scenes all over the time. And this way that the clusters are dynamically assigned or removed. The economy scaling policy works pretty similar, but it's not so aggressive. So some queries can be kept in queue up to 6 minutes. Yeah, and even after that, the new cluster is added. And in removal phase, it works pretty similar. Just the time is longer. Yeah, so it doesn't take 3 minutes to remove a single node. from multi-cluster warehouse, but it will take up to 6 minutes. So it takes more time to remove the cluster. So yeah, let's take 5-minute break, and then we can continue with the differences between the scaling up and scaling out. Yeah, so I will 5 minutes. I'm back. So let's continue with differences between scaling up and scaling out, and when to use what. So what's the scaling up? Scaling up is basically resizing the single virtual warehouse. So we are going either up or down from extra small to small or other way around. And why we do something like that? We need to handle more complex queries. We need to ingest more files, process more data. We have a complex queries to run. On the other hand, we have scaling out when we are adding clusters into multi-cluster warehouse, where we can go up to 10 clusters inside a single multi-cluster warehouse. And that's something what we will use to solve the concurrency issues. Yeah. As I described, multiple users opening the same dashboard at the same time. Someone was asking about the costs. So here you have a complete table. So yeah, it can go pretty wild. If you will go with, I don't know, 10 for extra large, it will be quite expensive. So yeah, still quite easily understandable, I would say. So you just multiply number of clusters inside with the basic credit consumption for the single warehouse. So summary, what scale up will do, it will boost up the performance for the complex queries. So it can help you with those data spilling issues because you will have more memory. It can also help you to ingest larger data sets because you most probably have more files which needs to be ingested. Yeah. It can help you with more complex queries, queries which have large joins or aggregations or Windows functions. And as I said before a couple of minutes, you should experiment with the warehouse size to find the right one for you. So it's completely fine to start with extra small one and scaling it up until you provide the best performance compared to costs for your own use case. Yeah, try to keep the similar queries on the same warehouse. Now you already know why. That's because of the caching, and it can also simplify the compute resource sizing. So it doesn't make sense to have like 3 or 4 different warehouses which will do the same if you can fit all the requests into individual warehouse. And yeah, if the load fluctuates over time, you either have multiple warehouses, which you can assign to that task in different time windows, or you can, of course, change the size of the individual virtual warehouse. And summary of the scale out, that's something what you would use for solving the concurrency issues, how you can control the adding or removing of the resources. It can be done statically or dynamically. So statically means that you will use the same value for min and max cluster count properties. Dynamically means that you will use different values for min and max cluster count properties. If you use a dynamic scaling, then you have you have those scaling policies which comes into the scene. So economy scaling policy and standard is the other one. When to use which. So maximized you would use when you have a static load and predictable load. Auto scale scaling mode you would use in case the load fluctuates over time, so it's not predictable. Again, from exam perspective, I would recommend to know all the details. What are the differences between scaling up and scaling out? What are the and when to use scaling up, when to use scaling out? What is the scaling policy? What is the static and dynamic control for adding and removing resources? All of that you can find in the exam. Okay, a few questions for you again. Let's see what you think. And the scaling modes are maximized and auto scale. That's the correct answer. Static and dynamic, it's not the name of them. It's the way how it can be done. Economy and standard are the scaling policies. Scaling up means adding more clusters into multi-cluster warehouse. Yes or no? Let's see. And false is correct. Yeah, scaling up means that you are changing the size of the individual warehouse, not adding clusters into multi-cluster warehouse. That's the scaling out. And how to configure the maximize scaling mode? Let's wait a few more seconds to give a chance to others. Okay, let's see. And wow, perfect. Yeah, almost all of you got it right. So you need to use the same value for both min cluster count and max cluster count. It's not enough to provide only max cluster count. So we always need to provide both values. We have a simple exercise here. We will just try to create a multi-cluster warehouse with following attributes. So let me share my screen again and I can show you a code for it. And let's move on because we have plenty of things ahead of us. So it's a pretty similar DDL statement like the single cluster, single virtual warehouse. So you define the size, but now you need to provide those additional properties for multi-cluster warehouse. So you define min cluster count and max cluster count attributes. You define the scaling policy, and the rest is the same. Like you can define the auto suspend time if you want to enable auto resume, and if you want to suspend the warehouse once you create it. Plus many others which you can find in docs. So you can even add the query timeout we discussed during the creation of the virtual warehouse. So you can add another parameter which will be query statement timeout in seconds and configure it here. Okay, Let's move on into table types and what can be impact of different table types on the costs. So storage basics, let's move on. We talked about that yesterday, and let's talk about the table types. I will open all of them. So what are the table types in Snowflake? We have, just quickly counting them, 4, I believe, 4 or 5 now already. So permanent is the default table type. So whenever you create a table in Snowflake, it will be permanent table type. What it means, it's permanent, so it's persistent until you drop the table. So until that moment, all the data are available. And as a permanent table, it has some data protection features available and enabled. By data protection and data recovery features, I mean there is a time travel period and there is a fail-safe period. Time travel is configurable. It can be up to 90 days if you are on the enterprise edition and higher. And fail-safe period is not configurable, is by default 7 days after time travel. And fail-safe is something what Snowflake offers as a disaster recovery. So it should be used when there is some disturbance in the cloud region where your data are stored. So Snowflake can, you can ask Snowflake support to retrieve your data from the failsafe, but it's not something what would be accessible for you, and you can retrieve the data from this failsafe on your own. Another type is called temporary. It's also persistent, but it's persistent only to the session where it is created. So it's tied to a session. So when there is an active session and you create a temporary table, it will live only during the active session. So it's something what you would use to store some, let's say, intermediate results, some transitory data. And once the session is over, the table is automatically dropped. So it means that there is no fail-safe. There can be time travel. The maximum is 1 day, but it means that the session needs to be active all the time. What are the other table types? We have transient, which is something between permanent and temporary. It's also persistent until you drop it. So this is the same for the permanent table. So it can be used by multiple users. That's not the case for the temporary table because the temporary table is tied to session. So it's available only to user who is running that session. But what's the difference between permanent and transient table is availability of those data protection features. There is no fail-safe for transient table, which means that there is also a cost save for storage on that end because you don't need to 1 day. And last but not least, we have also external tables or iceberg tables. In both those types, the data are not stored directly inside Snowflake, but they are stored in external data lake, and you just use a Snowflake engine to query those data. So the access is via external stage. External tables are read-only. Iceberg tables can be also modified, and iceberg table behaves more like natural or native tables inside Snowflake. External is, let's say, some old feature. I'm not sure if it's still heavily used once we have also the iceberg tables available. Of course, since those tables are not stored inside Snowflake, so there are no data protection features available. So no, let me go back here and just where you should use what table type. Transient tables, that's definitely something what you should think about to use for, let's say, lower environments, dev, Q&A, and test, because you can save some money for storage. You don't need to have a fail-safe period active for your development environment. Same goes for the time travel. If you have a time travel for 2 weeks configuring your production, you probably don't want to save and pay 2 weeks time travel for your development data. Inside production, you can also use transient table for, let's say, some intermediate layers of your data warehouse, some work tables. It's also fine to use transient tables for them. In terms of views, we have also a couple different types of views. We talked about the secure views already yesterday, I believe. So the default view type is a standard view. It works in the same way like a view in any other database. The difference between standard view and secure view is from a security perspective. So the definition of the view is not available. I mean, the definition of the secure view is not available to anyone else except the owner. Because of that, the query optimizer needs to bypass some optimizations. So querying of the secure view can be less performant compared to standard view. Then we have also materialized view. Materialized view behaves more like a table because the result is pre-calculated and stored. So whenever you access materialized view, the data are not calculated on the fly, but retrieved from the storage. Snowflake offers auto-refreshed materialized views. So whenever you access the materialized view, Snowflake guarantees that you access up-to-date data. So the refresh is done behind the scenes. And there is also secured materialized view. It works in the same way like the secure views. Let's talk about the materialized views a little bit more because it works slightly different in Snowflake. When to use it, what is it? It's obvious. You just store the result of the query and it behaves like a table. You can even define materialized views on top of the external tables. So this is the elegant way how to store the data, external data inside the Snowflake. Why to use materialized views? Of course, it can simplify the query logic. If the definition of the MV is some complex query, then you can hide it behind the name of the MV and the data are pre-calculated. So from edition perspective, materialized views are available on Enterprise Edition and higher. When you should use it, let's say that it's a large and stable data set. So some data which are not frequently updated, because if they are frequently updated, it means the underlying data are changing, and those changes will trigger the refresh of the materialized view. And of course, for refreshing the materialized view, you need a virtual warehouse. You don't need to provide a virtual warehouse, but Snowflake will use some system-defined materialized warehouse, not materialized, but virtual warehouse to refresh materialized view. But what's important, you need to pay for that virtual warehouse. So if you will define a materialized view on top of the table, which is refreshed in near real time, it can be quite expensive, to refresh it so often. So defining it as a table might be more cost efficient. The rule of thumb here could be that the query result of the materialized view contains some results which requires significant processing. Then it makes sense to use a materialized view because you do that significant processing just once, not every time you access that materialized view or view. If it would be view, you need to do that calculation every time you access it. So from cost perspective, it's the serverless feature. So there is delivered the system warehouse, not your own. It requires some additional storage because you need to save the result of the MV. And there is that maintenance cost. The maintenance cost is the cost related to refreshing the MV. And there are also some limitations for MV compared to other database systems. So what are those limitations? You can define the MV only on top of the single table. So joins are not supported for MV. So you can have a join of multiple tables inside the MV definition. Materialized view also cannot query another MV. So you cannot build MV on top of MV. it cannot query a view or user-defined table function. So it can really be defined only on top of a table or external table. There is also limitation related to what can be used inside the definition of the MV. So you cannot use window functions. You cannot use having clause or order by clause or limit clause, yeah, inside the MV definition. Also, many aggregate functions are restricted. Don't worry, those basic ones like min, max, count, sum, average, those are supported, but there is a list of the functions which are not supported. Again, from the exam perspective, it's worth to read the page related to the MVs and the limitations, because there might be questions asking you what are the limitations related to materialized use. And let's have a look on a few questions related to data types, MVs, and views. I hope you can select multiple items. If not, then doesn't matter. Let's have a look. Yeah, so permanent is correct, transient is correct, there is no session table. External is correct, user-defined. Well, all the tables are user-defined, but it's not like official type. Can you update the external tables? Let's see. And the correct answer is false. External tables are read-only. Yeah, I'm not talking about the iceberg tables. Iceberg tables can be updated, but the external tables can't. Which table type can be used by a single user only? Let's see. And yes, it's the temporary one because it's tied to session. Can the secure view get data from multiple tables? Let's check. Yes, there is no limitation for secure views in that sense. Let's have a look on the exercise related to normal and secure views, so I can show you how it works in relation to protecting the definition of it. Just a sec, I will share my screen. Just do it that way. Okay, I am inside my Snowflake account again. And let's try to create some views and secure views. Yeah, so quite simple view. We will add some aggregation. So for a given month, we will aggregate number of trips, number of users, and total duration. So let's create such view. We can query it. So we have some like summary per month. Let's try to get a DDL of it. So it's a normal view, so it should work, and it works. So we can see the logic behind the view. What is the source table and what are all the steps applied. Let's try to create the same view as a secure. So the definition of the view is completely the same. We're just adding the secure keyword here. And we have it. So we can try to query it. It will work in the same way. I can try to here. I want to close this. Yeah, so, and we can get the DDL because we are owners of it. And if I will run show views, you can find the view here, and it will be saying that it's secure. There is a secure flag, and it's true for it. Same, there is a flag for materialized view, so you would see it's the materialized view. What we can try, let's try to add some privileges to that, to both views, to our analyst role, and see the differences. Yeah. So we will use the analyst role now. We will disable the secondary roles for my user. So I will have only that analyst role active right now. And I will try to get the DDL of the secure view. And you can see I got an error that either the object doesn't exist or operation cannot be performed. So object exists, but since I'm not the owner, I'm not able to see the definition of the view. I would still see the view here in the list, and I can still query the view and get the data, but I can't see the definition of it. Cool. That was it. Let's move on to next, which is again related to optimizing some query performance. So we just talked about some query optimizations in general, some data spilling, and I can provide a little bit more details here. Just at the beginning, Snowflake by default does a lot of optimizations behind the scenes. So even though you are not thinking about doing some like performance tuning and optimizations, you still can get quite a lot out from the platform because a lot of it is applied automatically behind the scenes. So there is no extra effort needed from your end. But I think at a certain, let's say, phase in your projects, it might make sense because you will get more and more knowledge about Snowflake, and you might get some cost saves. So once you will start understanding all those concepts, how the platform operates, you can try to apply some additional optimizations. So maybe you will get better understanding of the caching. So you will do the proper planning of the virtual warehouses. You will know what is the best in terms of data loading. So you can optimize your file size. You can optimize the size of the virtual warehouses and how all of that will work. Yeah, but in general, Snowflake doesn't require any significant performance tuning. So there are no indexes in Snowflake which you would need to maintain and take care of. Same goes for partition management. If you are coming from Oracle, so you might be used to do some partition management. So nothing like that is. So let's go through the built-in optimizations. The partition pruning we covered already, so that's something what's happening automatically behind the scenes. You can just influence how well it will be done, either through auto clustering or through defining the proper filters inside your queries. So that's the way how you can help Query Optimizer with that. You will apply the appropriate filters. What's important, if you have like multiple CTEs, then it's best to apply the filters as soon as possible, just to filter out the data which are not needed before you start do any aggregations. Clustering, yeah. So let me list all the bullets first. We talked about the clustering yesterday, so let's add a few more details here. The clustering means how the data are organized in micro partitions. So that's the crucial element for the micro partition pruning and for the performance. The clustering, I mean the auto clustering, is not something what you would do for all the tables. So when it makes sense to think about enabling the auto clustering, so you have like large tables, and by large I mean the table is in terabytes in size. You have table where the performance degrades over time, so it's just not fulfilling your SLAs anymore. So you require some faster response times. Then you might be thinking about enabling auto clustering. So auto clustering means that you define something what's called cluster key, and cluster key could be a column or a group of columns, which helps Snowflake Optimizer to organize data along that column in the same micro partitions, or let's say micro partitions which are close to each other. That's the auto clustering. There is also something what can be called natural clustering, and natural clustering means that you will try to organize those data by yourself without defining the auto cluster key or cluster key. Why? Because the automatic clustering requires some maintenance, and the maintenance needs to be paid. Yeah. So I believe I have more slides, so we will see more details. Let's list all the bullets. So when you should consider defining the cluster key. As I said, the performance degrades over time, and it's not acceptable for you anymore. Or you just simply need to improve the performance just to have a better response times. Your queries are quite selective, so the underlying table is quite huge, but you select only a small portion of the data out of it. Or your queries uses sort operation. Sort operation is like one of the most expensive operations in Snowflake. So in that case, it also might make sense to define the clustering key. Should be much higher than number of the DML operations. So insert, update, and delete. Again, if you will try to define automatic clustering on top of the table, which is updated in real time, it can be quite expensive from the maintenance perspective, because Snowflake needs to keep the micro partition in order behind the scenes, so that there will be constantly running some maintenance. So automatic clustering, we define the cluster key, and Snowflake does the maintenance for us automatically. There is no, it runs behind the scenes, so no, how to say it, it has no impact on your queries or something like that. And Snowflake also provides some functions which you can use to monitor the health of the clustering and the costs. And if you want, you can also suspend the operation. I mean, suspend the automatic clustering. But once you do it, you can't query the table, yeah, during that period. So in relation to clustering, there are couple of, let's say, characteristic or attributes which you should know. Some of them are clustering depth and overlapping micropartitions. So clustering depth means the smallest depth is the better cluster table. Yeah, so that should be your aim. Try to achieve the smallest clustering depth. And you can use those values, what's the clustering depth and how many micropartitions are overlapping as some kind of indicators how well the table is clustered or not. So if you would have empty table, it means that the clustering depth is 0. So here we have a simple example where we have 5 micropartitions. So when all of them, and this is here, all of them are overlapping, the micropartition depth is 5. And it means that no micropartitions can be pruned because all of them contains similar values. So in our case, it will be values from A to Z. We improved the clustering a little bit, and now only 3 micropartitions are overlapping. So now the depth is 3, which is much better. And we can see that we would be able to do some pruning if we will ask for values between K and Z. It means that we can prune those 2 micropartitions. Another improvement, now the clustering depth is 2, so only 2 micropartitions are overlapping. And of course, this is the final state and the best what you can achieve when the overlapping is 0. So you have only unique micropartitions and the depth is 1. Of course, this is like ideal scenario and ideal use case. In reality, it won't be here, but I hope that you got the point what it is about. What are those system functions you can use? Again, from exam perspective, good to know them. Let me list all the details. So one is system clustering depth, and this will just compute the average depth of the table based on the input columns. So as a parameter, you just input the column. And if the table is already clustered, you can compare how it would behave if you would use different column. And system clustering information will provide a lot of other, let's say, characteristic related to clustering. So it will include the depth. You can also get the depth histogram, number of the micropartitions, what is the average overlap, total constant micropartition count. So that's something that can't be improved further. Natural clustering, that's another type of the clustering I was mentioning. Basically, that's something how you can simulate the automatic clustering by yourself. And once you ingest data into the table or load data into the table, you can order them along some of the columns which are heavily used either in the where clause or in the join conditions. And that column is something what you would define as a clustering key in automatic clustering. It might make sense to do it anyway for all the other tables because it can help the performance. Some time ago, I did also some comparison. I tried to compare automatic clustering with natural clustering. And yeah, the natural clustering behaves better, but there is also that cost associated with that. So many times it's sufficient just to use this natural clustering. Because once you order the data, let's say you will use some order date as a column for ordering, it means that once you are ingesting the data, loading data into the table, the orders from same date will be in the same micropartitions or partitions which are close to each other. So it can help with the pruning. Of course, if you are doing a lot of updates or deletes inside that table, it means that your order will be broken over time because there is no automatic reclustering behind the scenes. So once you will see something like the performance degrades over time, what you can do, you can like recreate the table and order the data again. Yeah, here is something what is related to database execution orders and how the Snowflake optimizer perform the queries. It's also something what you should have in mind when you start doing some optimizations, because you should start optimizing these things first. So first are done the rows operations, so from, close, join, and where. So once you start thinking about some performance optimizations, just focus on those areas first. Once the rows operations are done, then groups are done. So group by and having. And last, the results are processed. So select, distinct, order, and limit is performed. So a few more performance tips. Use the filters every time. If you can, add some filters as early as possible, just to limit the number of the data and amount of the data you need to process. Check the row operation first. I just show you why. The rows operation are performed first. So check from and where clauses, if you can add some more filters there. Then check the group by and having. The row operations are done before the group by. So yeah, it means that all the filtering is done before you do the aggregation. Try to utilize the caches. In terms of joins, I believe those are same recommendation you would see also in other database systems. So you should ensure that keys are distinct. You should understand what's the relationship between the tables before you try to join them. You should try to avoid many-to-many joins. Try to avoid some unintentional cross joins, because it can lead to some like join exposure. Yeah, so what is the exploding joins? When it can happen when you try to join two tables on not unique columns, and as a result you will have something what's called Cartesian join, where one record from table A will be matching multiple records from table B. And as you can see on the screen here, we have quite few hundreds of records in each table, but once we will try to join them on some non-unique columns, the result can have, like in this case, it's like 200,000 records. So it will take a lot of time, the output is huge, and it costs you a lot of credits as well. Because it will be running a long time. Few more questions for you. Another one. is a question in the chat. What was the correct answer for the first question? It was the automatic clustering, or auto clustering is the feature name. And let's see how to check the clustering information. And yes, you should run the system clustering information function. So other are not correct. I can see that you can experience some lagging. Let me try to disable my camera if it will help with bandwidth. Otherwise, I can also try to refresh my browser. Another question. Let's see. And the correct answer here is no, there is extra cost for table clustering. There is that clustering maintenance which runs behind the scenes and which is trying to reorder the micro partitions. So no is the correct answer here. Okay, we have a resource monitor and budgets ahead of us. We are just in the middle of today's class. Let's take 10-minute break for now, and we will continue with the resource monitors after 10 minutes. So let's try to refresh. Okay, guys, I'm back. I tried to refresh my browser and I will keep my camera off. So I hope that it will help with bandwidth and that my voice won't be lagging. Just let me know if it's okay or not. Let's continue with the next topic. It's called resource monitored budgets. So we will talk about I hope you can hear me. Just give me some thumbs up or down. I'm speaking, but not sure if you can hear me. Okay. Okay, let me try to continue. Let's see.
Yes, I can hear you now.
Perfect, perfect. So let's move on. Resource monitor. So what is it? It's some kind of automation in terms of monitoring of your spendings related to the virtual warehouses. So you will get some notification in case you will reach your defined limit. And there can be also done some action, like you can suspend the warehouse automatically when you reach the limit. So the resource monitors helps you to keep the costs under control, and it can help you to prevent all the unintentional cost spikes. Like I mentioned that query timeout default value for 2 days. So if it can happen that you will have a bad query running for 2 days, if you would have a resource monitor with the proper action in place, it can kill all the queries quite early, depends on your configuration. So it can help you, prevent from the bad user queries. You can also have some long-running ELT pipelines or ML models refresh, or as I said, missing configuration for the query timeouts. So what is it? It's account level object, which means that there is an owner and there is a set of privileges which you can assign to resource monitors. It helps you control the costs, and it has several properties like the credit quota, which is the limit of credits which can be spent on the given warehouse. We have two types of the resource monitors. Either we have account monitor, which monitors all the spendings for a given account. Or it can be warehouse monitor, where it can monitor individual warehouse or group of warehouses which are assigned to the same resource monitor. Then there is a schedule, so how frequently the limit should be reset. It can be on daily, weekly, or monthly basis. And we can also define start and end times. And of course, the actions, so what should happen when the limit is reached. Warehouse can be assigned to single monitor, but you can assign multiple warehouse to the same monitor. Account level monitor does not override the monitor which is assigned on the individual warehouse, so it's still in place. And the account level monitor doesn't control spendings related to the system warehouses, like warehouse for Snowpipes or warehouse for MV refresh and auto clustering. Those are not controlled by account level warehouses. So how the assignment can look. So here we have three different resource monitors. So you can see that we have one account one, the red one with credit quota 1,000 credits. So all the virtual warehouses which we have in account are assigned to that resource monitor. Then we have two more. This one with 200 credits, there is a single resource monitor assigned, and the last one, 500 credits, and we have two assigned resource monitors. Two virtual warehouses assigned to single resource monitor. So what are the actions? So what should happen when the credit quota is reached? It's defined as a percentage of the credit quota, and you can also define threshold which should be greater than 100%. We have three types of action: notify, notify and suspend, and notify and suspend immediately. So what are the differences? Notify will just send a notification to account admin that you just reached that limit. Let's say that you will define a notify at 80%. Notify and suspend means that it will again notify the account admins and suspend the warehouse. And notify and suspend immediately. So what's the difference between those two? The notify and suspend will wait until all the actively running queries will finish and then suspend the warehouse. So nothing new can be submitted, but it will let finish everything what's running. Notify and suspend immediately doesn't wait for anything, and it will just kill everything what runs and suspend the warehouse immediately. Yeah, so you can define all three actions at the same virtual warehouse. So let's say that at 80% you want to be notified, and at 100% you want to notify and suspend, and at 105% you want to notify and suspend immediately. So you don't want to wait more, because what can happen? Yeah, there can be some bad query, long-running query, which will be running for hours or days, and you will just reach your quota, and it can be still running for another 2 days. So that's why we have also suspend immediately, so it will not wait for anything, and it will just kill the action, kill the query, and suspend the warehouse. Once you create a resource monitor, it will start monitoring the credits immediately, but you can also provide the start time, and it will be resetted at the beginning of the month. You can also provide custom interval if the daily, weekly, monthly, yearly doesn't fit your needs. And as I said, it can start immediately or at specified timestamp in the future. Budgets. That's another feature related to you also define a limit in budgets, a monthly limit for your spendings. What's the difference between budgets and resource monitor? So budgets doesn't have any actions, so it's just purely for monitoring purposes. It can't like kill any processes or suspend the warehouses. What you can do, you can define different groups of resources which you want to monitor. So let's say you want to know the spendings for all the containers which are running inside your account, or for all the materialized views, or all the pipes. So you can define different budgets for different groups of objects and then monitor the spendings on them. So they provide like more granular overview than Resource Monitor, because Resource Monitor are just on the warehouse level. Here you can go on the resource level, like the different objects inside Snowflake account. Of course, they can also send a notification. There are different options here. It can be email, SQS, or some webhooks. And yeah, as I said, it's just an informative character. They can't shut down anything natively. And there is a nice UI with some dashboards which you can use and see how it looks. Yeah, here is the UI. So there is also some projection, how it thinks it will be for the rest of the month, and how are you with your spendings currently. Exercise. What we will try to create some resource monitors and assign them to account or virtual warehouses. So let me share my screen again, and let's do that. So resource monitor by default needs to be created by account admin, or of course you can create a custom role and grant needed privileges to that custom role. So how it looks. This is a DDL for resource monitor. We define the quota, the frequency. We want to start immediately, and we have all those three actions. So on 75%, we want to notify, 98, we want to suspend, and on 100%, we just want to suspend immediate. Let's recreate this warehouse. There is also show command, so you can see all the all the resource monitors which you have, and what's the current use credits for them, and how the assignment works. So you just do alter warehouse and set resource monitor, and the name of the resource monitor. You can see the assignment in the show warehouses command. There is somewhere resource monitor, I believe. Yeah, here. So see nothing currently. So let's alter our compute warehouse, and we can check again. Now we will see that our compute warehouse has this one. Let's create one more, which will be account level. So again, we just create another resource monitor with 1,000 credits as a quota, and with just this suspension. And basically this one, once we assign it to whole account, means that once we reach those 1,000 credits, all the warehouses which we have in account will be suspended, and you are not able to enable them again until the clock is resetted, so at the beginning of the next month, or you need to just disable the resource monitor. So we can assign it to our account. Okay, that was it. We can move on to next topic, which is stored procedures and user-defined functions. So again, something from data engineering, and it's quite similar, stored procedures and user-defined functions. So let's talk about stored procedures first. So stored procedure in Snowflake works in similar way like in any other database engine. So it's trying to extend the SQL language with some procedural logic. So you can define different loops, conditions, variables, cursors. You have a transaction support. You have error handling inside. And you can run the code through stored procedure. So Snowflake supports different languages for writing stored procedures. So apart from the SQL, you can write stored procedure also in JavaScript, Python, or Java. You can have like nested calls of stored procedures. So inside stored procedure, you can call another one. Stored procedure cannot return a set of rows, so you cannot return a table, and it can return nothing. So there is like void procedures. Returning void or returning nothing is possible. Use cases for stored procedures, yeah, plenty of things what you can do with stored procedures, starting with some task automations where you need to combine multiple SQL statements, or you need some additional logic so you can bundle everything into a single stored procedure and call it at once. Typical use cases could be some database cleanup if you need to remove some data which are older than XYZ days. You need multiple delete statements, and you just pass the date, or you want to enable delete data from some other tables to roles which doesn't have privileges to delete the data, so you can write a stored procedure for them. Database backup you can perform with stored procedure. Some ELT pipeline, ETL pipeline, even though I don't think it's the best nowadays to use a stored procedure for that, but you can definitely do that. Here we have a simple example of stored procedure written in the SQL. So at the beginning, we have a declare part where we define our variables, and then we have begin and end where we have a logic of the stored procedure. So this one is quite simple. It just calculates area of the circle and return the value out of the stored procedure. So it doesn't accept any input parameters, and it returns varchar. Yeah, so maybe you are asking how to choose the right language for your stored procedure, if there are so many. Yeah, there is no like recommendation. You should select the language based on your own preference. So maybe you already have some code in that language, so might make sense to use the same one, or maybe you just know that language. Again, it might make sense to use it, or that language has some capabilities which you need, or some libraries which might be useful for you. Or what can help you to decide is if you want to have a handler code inline or staged. Inline means that all the code you have as a part of your stored procedure definition, and staged means that you have a separate file stored in your Snowflake stage with your code, and it's just referenced inside the stored procedure definition. As you can see, SQL and JavaScript supports only inline handler, so you can't stage the code. Other languages support also staged code. Here we have another example of stored procedure with inline handler. So you can see directly in the definition of the stored procedure, we have a code of it, the logic. So how you would probably work with that, you develop and test the handler code locally just to verify everything works. If it's a code which requires compilation like Java or Scala, you would compile that code. Once you are done, you would copy it into Snowside and create a stored procedure. On the other hand, here we have an example where we have staged handler. So you can see, in this case, it's the Java code, and we just import, in this case, compiled code into the stored procedure. So it's stored in the stage, and you just say what's the handler, what's the method which should trigger the stored procedure. So again, the way of working would be pretty similar. You develop and test the handler code locally, compile it, upload it to the internal stage, and then you would create a stored procedure, and you would just pass the file with the code. Yeah, so what are the advantages, disadvantages between inline and staged handler? So let's start with inline one. Of course, it's easier to implement because you have everything inside a stored procedure. You can simply update the code with alter statements. So if you need to change something, you will just alter the stored procedure and it will update the code. You maintain everything directly in Snowside. And of course, if it is compiled code like Java or Scala, you can define the location for the output path with the target path parameter, and then basically the code is not compiled with every SP call, but it's stored. I mean, the compiled code is stored at the target path, and it's just referenced with the SP call. On the other hand, if you have a stage handler, it might make sense if you have a code which would be too large for the inline handler. So if you have really complex code, which is quite hard to like maintain inside the stored procedure definition, then it might make sense to define it as a standalone file. You might also want to use a code which is used somewhere else. So again, might make sense to reference just the file somewhere in the stage, and it might be also easier to debug it or test the code if it is some complex one. One more thing related to stored procedure, and that's the callers or owners' rights. Because once you call the procedure, you have two options. Either it will be called with callers' rights, or it will be called with owners' rights. So let's start from the right side this time, because the owner's rights is default option. When you don't specify anything, it will automatically run with owner's rights. So it means that it will run with privileges which the stored procedure owner has. It might be the case that the stored procedure owner has some privileges which are not assigned to a user who is calling that stored procedure, like delete data. So that's the case when you can, let's say, enable other roles to do some operations which they cannot do themselves directly. Yeah. So you want to delegate some task to another role without granting those privileges to them. Typically delete data. Yeah. So if you want to enable users to delete data from some of the schemas where they don't have that privilege, you can write the stored procedure for them where you have under control what will be deleted, and just give them privileges to run that stored procedure. The disadvantages could be that you don't have access to the session state, you can't change it, you can't set or unset the session variables which the callers might have. So on the other hand, you can run it with the caller's rights. So in this case, it will run with privileges of the caller. It knows the caller's current session, so you can use inside the stored procedure session variables and parameters. You can modify them inside the stored procedure, and all those modifications will be also active after the stored procedure will finish. So, yeah, you are limited to privileges of the caller. So if the caller can't do something, some action, it can't be done also inside the stored procedure. So yeah, just a simple rule of thumb here, use the caller right only in case you operate around the objects which the caller can do, and use it also only in case you want to manipulate or you need to have access to session variables or parameters of the caller. Otherwise, you can go with the default option and owner's rights. User-defined functions. It's pretty similar to stored procedure in terms of supported languages, so it supports completely the same languages. Yeah, typical examples, you want to calculate something like profit per department, area of circle, or this kind of stuff. So where there is missing some built-in function, you might want to write your own. If you need to share a function, UDF can be shared, but then only SQL and JavaScript UDFs can be shared with other accounts. There is also secure version, so also the UDFs could be secure. Again, that's something what will be useful for data sharing. User-defined functions are called from SQL query, so there is no special call keyword for it, but you would call the function inside the SQL query. You can't do DML or DDL operations inside, and function always have to return some value. Again, here we have a simple definition of the function. just add 1 to input value. You can see it's in Python in this case, it returns integer. You will have to specify also the runtime version. And then here you have how to call it. So call the function directly inside the select statement. And this is also the example of inline handler, because it's the same for the UDFs. Like for the stored procedure, you can also use staged handler for UDFs. We have two types of UDF. It's the scalar function, which returns a single value for each input row, or we have also the tabular function, which returns a row set or a table, if you want, for each input row. For the tabular one, the return value specify the schema of the return table. So you need to specify all the columns together with the data types which will be returned from that UDF. Body of user-defined table function is a SQL expression, so there must be a SQL statement, select statement. There are some limitations for input and output parameters. You can use maximally 500 parameters. And you already know table functions most probably because the information schema is full of tabular functions. So you also know how to call tabular function. Yeah? So there is a table keyword, and inside you have your UDTF name plus the parameters. Let's try to do some exercise. So we will try to create some simple, I believe it's only the scalar function. We will use our landing table, Snowpipe landing table, and we will try to extract a domain information from emails we ingested into that Snowpipe landing table. So I am back in my Snowflake environment, and if I query that table, you can see that we have a column called email. So maybe we would need to extract just a domain part of the email. So we can write a custom function for that. So we don't need to do it every time. So let's try to write a function called getEmailDomain. As an input parameter, we will pass the email value. So it will return a string. We want to write it in Python. 3.8 will be the version. Handler code or the function inside is called domain extractor. So it's quite simple code. We will just find the index of the add character and then return everything what is after the add. So let's create a function and we can test it. So we will call it as a part of the select statement. So we will select the email and then our user-defined function. And you can see we just extracted the domain. I added the condition here. If I would remove the condition and try to query it, I will get some Python error saying that there is no add for some of the values. And that's because our Snowpipe landing table can contain also empty email. So the email could be null. So we should improve our code a little bit and do the extraction only in case there is some email available. Yeah, so if there is an email, let's do what we did before. If the email is missing, we will just return that the provided value is not a valid email. So let's try to recreate that function. And this time we can query the table without the condition. And what you can see here is empty email. And for that, we got not valid email as an output of our user-defined function. So that was simple UDF. And let's move to next topic. We will stick to the data engineering and we will speak about features which are called streams and tasks, which are quite popular for building data pipelines directly in Snowflake. So let's start with the streams. So what are the streams? Streams is change data capture or CDC feature inside Snowflake if you want. So they helps you identify and act only on the changed records. Basically, the stream will add some metadata columns to your table, and those metadata columns will track changes inside your data. Because we are adding some new columns, there is some little storage required, but nothing what you should be worried about. And what streams, how streams can be used. Once you define the stream on top of the table and something has changed, you can query the stream, means that you will consume the changes as you would do with standard table or view. Once you consume the changes as part of some DML operation, typically you would run some update or insert or delete statement with the stream. Then it means that the stream will be consumed and it will be cleared, like it will be empty until another change is done in underlying table. So the stream itself doesn't contain any data. It's just the pointer in time. So you can see we have our table T1 with single column and 4 values, and we did some updates. So B has become E and D has become F. And then we have a stream object, and that stream contains only the changes. So inside the stream, you can find E and F, plus there will be some metadata related to those changes. What are those metadata? So we have 3 metadata columns, and they are called metadata action, metadata is update, and metadata row ID. So action means what kind of action has happened with that row. It can be insert, update, or delete, obviously. Metadata is update is just the flag saying if it is part of update or not, because update is tracked as combination of insert plus delete. And row ID is just some internal ID of the change. We have some multiple types of the streams. We have a standard delta stream, which tracks all the changes, insert, update, deletes. We have append-only streams, which tracks only the inserts. And we have also a stream which is called insert-only stream, but that one works only on top of external tables. So which objects are supported to track changes by streams? So you can define stream on top of tables, on top of directory tables, or on top of external tables. You can also define streams on top of views. Yeah, so here we have a data flow for the stream. As you can see, we have a version 1 here at the beginning with single row and 2 columns. Action is saying that we just insert that record into the table, so it's not update. Next version, we just added 2 more items and we update the original one. So here you can see how it looks in the stream. So we have those 2 inserts, and the update here is tracked as a combination of insert and delete. So there is a flag metadata is update is true for that too. And you can also see that row ID is the same for those 2. And then we did some delete. Again, we can see delete in the stream. A few more parameters related to streams, and that's the data retention and stainless. Because once some changes are tracked by the stream, they need to be consumed within some defined period of time. If they are not consumed, the stream will become stale, meaning that it's not usable anymore, and you just need to recreate the stream again, but all the changes tracked by the stream are lost. So default value for data retention is 14 days. So you have 14 days to consume the changes. If you want to change that, there are 2 parameters which you can use for that, and they are called data retention time in days or max data extension time in days. You can use whatever parameter or combination of those 2. How you can check if the stream is stale or not? You can run either describe stream or show streams, and in the output you will find stale and stale after columns. Stale is just a flag, Boolean flag, true, false, if it's stale or not. And stale after is a timestamp column saying when the stream will become stale. Some wrap up. If you need multiple consumers for a stream, you need to create an individual stream for every consumer. Why? Because once the changes are consumed by the first consumer, they are they are gone, so the other consumers would not see any changes. So there is no extra cost related to using streams, apart from that small portion associated with the storage. But the main cost related to the streams will be for the queries which you will run to process the data. And to create a stream is pretty simple. Here we have a simple DDL. It's just a create stream, the stream name, and on which table, and that's all. Well, let's try to create some streams and work with that. So what we will try to do, it will be combined exercise for also other parts related to tasks. So we will try to simulate that we are receiving some data on monthly basis. So we'll create a new table, which will be called trips monthly. And inside that table, we'll manually insert some data. And then we will try to build some aggregation logic on top of that. So first we will use streams to track changes inside the trips monthly table. And later we will try to combine that with the task. So the task will be automatically triggered by newly added data. So let me share my screen again, and let's try to create a stream first. So as I said, we will create a new table first. The table will look like our trips table, but let's call it trips monthly. We will just insert there some monthly data. And then let's create a stream on top of our newly created table. We can run the show streams now. And how it's called? It's this one. And let's scroll to right, and you can see there is a stale and stale after, so it's not stale, and it will become stale on 17th of February. So I use that default 14 days value for that. There is also system function called system streams has data, and you pass the stream name, and it will tell you if there are any data in the stream or not. So false, there are no data right now. But we can also try to query the stream. As I said, we can query it in the same way like we would query a table. And you can see it's empty. So what we will try, let's try to insert some data into the underlying table, which is the trips monthly in our case. So let's select all the trips from January 2024 and insert it into trips monthly table. Once we insert that, we should see some data in the stream. So if we will query that system function again, now it's saying true. We can try to query that stream and we can see the data. So basically those are all the changes. So that new data we added into that table. If we want to check what kind of action has been done, so we can query those metadata columns from the stream. And we can see that it's only insert. So we just inserted the data. So let's try to create some aggregated table. For a given month, we will just calculate number of rides, what's the total duration, and what's the average duration for the ride. And then we will try to insert some data there to consume the changes from the stream. We just created a table, and let's try to insert the data into that fact rides. But now it won't be inserted from a table, but let's use a stream as a source. So we'll be selecting data from the stream. And since we will use it inside the DML operation, inside the insert statement, it will cause that the changes from the stream will be consumed. And after successfully finished query, I mean this one, the stream will be cleared. So there will be, again, no data until new changes will arrive. So we just inserted one record, yeah, because we have 1 month there. We can check, and yeah, we have some summary for January 2024. And if we will query the stream now, it will again tell that there are no data. Perfect. That was part related to streams. And we can continue with the tasks, because that's the next part. And basically task in Snowflake means it's some kind of scheduled execution of the SQL query. So what you can do, you can take a single SQL statement or stored procedure call and schedule it. Then it becomes a task. And what it makes it powerful, you can combine it with the streams, so it can react on the changes. You can, as a schedule parameter, you can, or trigger parameter, you can use either some schedule like cron syntax, run this every Monday morning at 9 a.m., or you can specify the interval, run this task every 2 hours. You can use a predecessor, because you can chain together the tasks, like you can see on this image. So you can use as a trigger for T2 task, please trigger that one once the predecessor is finished. You can define the condition, so trigger the task once there are new data in the stream, or you can also trigger it manually, so there is execute task command. Use cases for the tasks, that's pretty wide. Yeah, you can use it everywhere where you would need to do something and schedule it. Copy data into Snowflake, out to Snowflake, run some complex ELT pipelines which transform the data into multiple stages. If you need to generate some reports, you need to perform database backup, some cleanings, keeping your aggregations up to date, whatever you want. Basically, every SQL statement can be scheduled through tasks. How to create a task? It's quite easy. Here we have a DDL statement for it. So there are some parameters which you need to provide, like warehouse schedule, when it should be triggered, or after what it should be triggered. We can also define if it should be automatically suspended after some number of failures. Once you create a task, it's automatically suspended, meaning that it's not running. Yeah. So once you create it, you have to also alter it and change the state into resumed. So let's have a look on the DDL here. So what we are providing, the warehouse where it will be running, the schedule, so it will run every minute, and the body of the task, so the SQL statement which should be triggered. So in this case, it's insert statement into the customer dimension, and it will select data again from some stream. And there is also condition, so we want to insert into dimension only the rows which have been inserted into source table. We can also add a condition that this task will be triggered only when the stream has some data. This is done here. So you can notice that we added one more parameter called when, and inside when we use that system function for the stream and pass the stream name. So how this works, the task will be triggered every 5 minutes, which is defined here. And every 5 minutes, as a first thing, what it will do is check the stream. If the stream has a new data, perfect, it will perform the code, so insert data into dimension customer. If there are no new data, then nothing will happen, and it will try again after another 5 minutes and check again the stream if there are no, if there are some new data. Yeah, you most probably want to also retrieve some history to know how it performs over time. So there is a task history, either a view or table function. Yeah, the same limitation applies here. So table function contains only last 7 days of history. In the view, you can find the last year. So examples, how we can query a table function. We need to provide the name of the task And you can also provide some time range. If this task, which is running every 1 minute or every 5 minutes, then you want to limit the output. Perfect. So let's continue with our exercise. And now we can try to define a task. And the task will do automatically what we did manually. So it will react on the changes in the stream and automatically insert the data into our fact rights table. Let me share my screen again. And let's do it. Yeah, by default, the execute task privilege is available only to account admin. So we want to pass it to sysadmin in our case. And we can again use sysadmin. So let's recreate the task. It will run on our compute warehouse. It will be scheduled to run every 1 minute. You also can provide some command. We define the condition. So it will be triggered only when there are some data in the stream. And as a code, what it will do is insert data into our fact table. So let's create a task. We can run show task now, and you will see that it's suspended. The state is suspended. So we need to resume the task. But nothing will happen now because the stream has no data. So once this will be triggered, it will check the stream, no data, nothing will happen. So what we will do, we will insert the data into the source table with next month data. That means that new data will become available also in the stream. And we just need to wait until the task will run. Now the final fact rights table contains still only the January, so let's give it a while, and it should automatically trigger the code and insert another month into the fact table. So if we want to check the history, we can run something like this, and we would see, yeah, because I haven't provided any filter, I need to find my task and see that it's the scheduled, so it will be triggered soon. And now you can see that another month has been processed. So if I would trigger query the stream again, it will be empty because it has been processed. Perfect. That was the second exercise. We have one more. But before, let me add a little bit more details related to the tasks. Yeah, you might be wondering that it might be good to provide some more overview related to how task runs. So what you can define is something what is called error notification for the task. So, and then once the task or any task in the tag will fail, you will receive event notification. The event notification will be the AWS SNS. So it will send AWS SNS. And then, of course, you need some additional logic on the cloud provider side to process that SNS message. So you can have some Lambda function, which can send info to your Slack channel, which is monitored by our operation team, and then can immediately see what has happened, what task has failed, and react on that. So how it is done, when you are creating a task, you just add another parameter called error integration, or it will be the integration name. Yeah, if you would like to know more, I have a step-by-step guide in detailed overview in my one of my blog posts, so you can find it on Medium. And we also talk about that a little bit more in detail in the data engineering course. So some details related to tree of tasks. The tree of tasks, there always needs to be a single root task. And there is only single direction supported, so you can't have loops, so you can go back from T2 to T1. Some numbers related to limitations: the single DAG can be up to 1,000 tasks, and every node can have up to 100 predecessors and child tasks. So if you need to update any task in the DAG, you first need to suspend the root task, then you can suspend your desired task, update it, and then you need to enable both of them again. How to see the dependencies like I have here. Again, you have two options. There is a UI for that in Snowside, or you can use a table function called task dependence, and you will get the relation between the task in the code. Here you can see how to get the DAG and task history in Snowside. So you have to navigate into database schema where you have your task, then open one individual task, and here you can see what is the DAG, what are the references between individual nodes, and another tab here shows the task history, so you can see some dashboard and how the task have run over the time. Some best practices related to stream and tasks. I already mentioned that with multiple consumers. It's also good to create a separate role which will be managing the task, like some task admin, and grant the execute task to it, or at least grant it to sysadmin or any other role, and don't use the account admin for that. It's also good to have some robust operation system around the pipelines, because if you will be using that for running some production workload, you want to be notified about certain situations, like you want to have some stream stale prevention. So if something will happen and the changes will not be consumed, you want to be notified about that. You want to be notified about some failures of the task, or if the task has been suspended accidentally, you also want to be notified, because that's, at least it's happening to me quite often, that I need to change the task. I just suspend it, and then I just forgot to put it back into resume mode, and then I'm wondering why it's not running. You also want to have some pipeline overview. So what you can do, you can prepare some dashboards where all of that can be visible. So this is one of my custom dashboards built around Snowflake metadata, so I can have a complete overview about what's happening around the pipeline. And let's add the last exercise. And the last exercise, we will add just another task. So we can create a DAG consisting of two tasks, and we will add another processing. So once we insert the data into our rights aggregation table, we will add another record into our log table saying that we insert something into the predecessor table. So it's pretty simple example, but I just want to show you how to define the relation between the tasks. So let's create another table, log fact writes. It will have just two columns, max loaded month, and what is the inserted date. We have a table, and now we want to add a task. So we first need to suspend the original one, because we want to add it after that. Let's add another log task. And here you can see that we are adding after parameter, so it will run after the original T rights aggregation task. And what it will do, it will just select maximum month from our fact writes and insert it into the log table. So we have a task. We can resume both of them. First, we need to resume the child task and then the root task. And what we need another data in our source table. So we add another month, which will make those data available in the stream. Because the data are available in the stream, it will trigger the original aggregation task. It will insert the data into our original fact rights table. And once the data are inserted there, it will trigger the newly created task for logging. So we just need to wait a little bit to process all the steps, and then we should see here another month, and in the logged table we should see just 1 month, which will be logged there. So it can take some time because the schedule of the aggregation task is 1 minute. So during 1 minute it will try to check the stream. So let's try again. And now we can see that the March has been processed. We can check the log if it's already there, and the log also contains that one record. So perfect, we are done. So we can do some cleaning because we don't need it anymore. We will truncate both tables and we will suspend the task so they don't need to be running. And let's move back. And we just finished another hour, so let's take final 5-minute break before the final hour, and then we will continue with flattening semi-structured data. Okay, guys, I'm back, and let's continue with the final hour. We have still a lot of topics ahead of us, so I'm a little bit worried that we will not manage all of them, but that's expected. I've included a little bit more slides, and we have time just to provide you like more knowledge, so you can go through the slides on your own. But let's continue until we will be running out of the time. So flattening semi-structured data. We touched processing semi-structured data slightly yesterday when we talk about ingesting data from Parquet and then preparing some JSONs. Now let's take it from the other way around. When we have a JSON and we need to extract data into individual columns. So let's talk about the data types first related to semi-structured data. We have 3 types. First is variant, which can hold any standard SQL type. It can also include arrays or objects. So non-native JSON types are stored as strings. There is a limitation. I think it's not true anymore that it will be 16 megabytes, but it has been extended recently to, I believe, 128. So quite a lot. And basically, you would use a variant for all the types of semi-structured data, hierarchical data. You can directly store the JSON data there. Then we have object data type, which is only the key value pair. Still, internally inside Snowflake, it's a variant, same like the array. If you want to use array data type, you can, but it still will be stored as a variant. Same limitation related to the length. For the arrays, it's like you can access items inside the array based on the position. The size is dynamic, and you can also have a nested array, so array of arrays. If you are not familiar with the JSON, so here we have a simple example of the JSON structure. So this is the key. Inside the key, we have some another object, and we have there also the array with 3 items. How we can load a JSON data into Snowflake? We have 2 options. We can either store the semi-structured data into single variant column, meaning that we will not do any flattening and we will store the document as it is. Or we can flatten the nested structure and extract the individual values and store dates and timestamp into timestamp columns, numbers, and this kind of stuff. So what way to choose? I would say it depends on you and it depends on your use case. How I usually do it, I ingest the data as they are into my landing layer or staging layer, and I do the flattening in the later phases. So I'm trying to keep the original data as they are. So flattening the data or extracting the data from the JSONs and from the nested elements. For that, you would use a function which is called flatten that can extract elements of another nested elements, and it's usually combined with special type of join, which is called lateral join. Lateral joins enables you to refer to columns from other tables, views, or table functions. So here we have an example how something like that can look like. I have it on the next slide. Yeah, so we have this structure, and when we use a lateral flatten, it looks like this. So what we extract are individual elements from the array, which is a size, and it's a product name. And you can see that the array has 3 items. So we have 3 rows, 1 row for each array item. If I will go back to previous slide, how we did it. So this is our input. We added the lateral flatten, and as an input parameter, we just need to add the key which we want to extract, and then the keys inside the array which we want to extract. We also provide the data type we want to use, because everything inside the variant is just a string. So if we wouldn't provide this typing, the values here extracted would be in the double quotes. Yeah, so still as a string, so you couldn't work with numbers as numbers, because it would be still a strings. Yeah, here I have it. So we need to provide that that casting with that special operator. What are other functions you can use for working with the semi-structured data? Array handling, we used this yesterday, the array aggregation. There are also some other functions like toArray or array size. Object construct, we also used yesterday. There is few more functions related to working with objects. There is a function for parsing JSON. Flatten, we just talked about that. For casting, you can use S and table type. If you need to check what kind of data type it is, you can use is and table type. Once you run the lateral flatten, it has the output has multiple columns. We just use this value column before, but here you can see what are the other values which you can get out from the flattening. I have to say personally that I also use only the value, but there is plenty of other metadata. Here I have an example where you can see how the individual values look like. So if you do flattening of this simple JSON structure, you can see what kind of values you will get for other columns in the output of the flattening. Yeah, another exercise. This time we will have a look on how we can do some flattening. So first we need to again prepare some JSON structure with those array aggregation and object construct functions. Then we can do the flattening. So let me go through it. You know this query from yesterday, so we will just create the semi-structured data first, something like this, and then we can flatten it. So let's create a new table with the query. Now we have it stored in the table. We can try to select it, so you will see that it's that JSON structure. Yeah, and now we can use the flattening. So what we will try to extract the data back into the relational form, how it was. So we will use the flattening. So we are selecting data from our new table, and we add that, I want this. And we add the trips. If I will go here. So we want to extract data from this trips array. Yeah, so the other key value pairs like day and station name are available directly. Like you can see here, we directly can go into the day key or station name key, and the other comes as an output of this flattening. So there is a f dot value is output of the flattening, and then individual keys inside the array, duration and station membership type. And again, we need to provide the typing. And we can try to run that. And voila, we have the data extracted from a JSON document into traditional table, into relational form. So that's the way how you can work with JSONs. So once you will know and master those couple of functions like array aggregation, object construct, you can create the JSON structures, JSON documents, and once you will master the lateral flatten, you can extract everything from those JSONs. Of course, if you would have array of arrays, then you just put another level of flattening and another one and another one. So this is the way how you can extract the values from the nested arrays. That's it. And let's move to next topic, which is data protection features. Let's mention a little bit more details to zero copy cloning and time travel. I mentioned yesterday when I spoke about storage layer of the architecture. So zero copy cloning is a feature which will help you to quickly take a snapshot of either table, schema, or whole database. So it's usable for quickly spinning up lower environments with the production data, and there is no additional storage until you do some changes either in original object or in the cloned object. It could be also quite effective way how you can perform backups. Both cloned objects and original objects have their own life cycle. So when you do some changes, it will be changed, but it will be changed on the micro partition level. Not all the objects can be cloned. And there are exceptions, like you can't clone the objects directly, but once you clone the upper level container like schema, then it means that also the object which you can't clone directly will be cloned. And you can find the details about what can be cloned or can't be cloned in documentation. So yeah, how it works. When you clone the object, all the objects share all the micro partition. All this object, meaning the original one, owns the micro partitions. Both of them share them, and clone reference them. In terms of access control, once you do the cloning on the database or schema level, that it inherits all the granted privileges on the child objects. So all the if you clone the database, everything on schema level and below is inherited, but not on the object itself. So the privileges on the database level needs to be granted again if you need them. And yeah, we have simple schema. So we have original object, we create a clone, and when we do some changes, the changes are done only on that small portion of the data, meaning on that micro partition level. Also, only the micro partition will be updated, not all data. Time travel is the second one I spoke about yesterday. So this one is something what gives you ability to access historical data at any point in time within the defined retention period, when the retention period could be up to 90 days. If you are on the enterprise edition and higher, on the standard one, standard edition, it is 1 day. This is a great feature if you need to investigate some data issues, because you can have a look on data in exact point in time. So most probably you want to check how the data looked before you applied some changes. There is also undrop command. So if you drop something accidentally, you can like undrop it. You can also do some restore or backup based on time or ID of the query. So if you know that some change has been done by particular query, you can get out the ID of that query, and then you can run the query, please give me everything before this query has run. So for working with the time travel, there are special keywords for SQL at and before, so you can get the data before some query has run or at a specified timestamp. As I already said, it requires some additional storage. So if you will define time travel for 90 days back in time, you need to store 90 copies of your data. And you can, of course, combine time travel with cloning. So you can clone the database at given point in time. Something related to retention control of the time travel. There are again some parameters which you can use for that, and there are 2 of them: data retention time in days. You can set it on different levels. You can set it on account, database, schema, or table level. Of course, the lowest level takes a precedence. So if you would have it defined on all the levels, then the lowest has a precedence. And there is also another parameter which can be defined only on the account level, which is called min data retention time in days. Yeah, a little bit related to syntax, how to query data using time travel. So as I said, there is a special keywords at and before, and you can provide following parameters. So you can provide a timestamp. You can provide an offset, which will be time difference in seconds, and you can provide the query ID, which will be the statement. So you want to get the data before that statement has run. And here we have simple examples. So select everything from my table before, how it looks before 10 minutes. Yeah, so a little bit more examples. This is that one for 10 minutes ago. If we want to query the data at given timestamp, so we can use at timestamp and provide a timestamp. And if we want to get data up to changes made by the query, we can use this before statement and the query ID. Failsafe, I also mentioned that a couple of times. So the failsafe is, let's say, the last data protection feature, and it's the last instance where you can get your data in case there will be some disturbance in a given region. So on the schema here, you can see how it works. You have your current data, then you have a time travel, which can be between 1 and 90 days. And after that, we have a failsafe, which is additional 7 days. As I already said, there are no user operation allowed. So if you want to retrieve a data from a failsafe period, you need to ask Snowflake support to give it to you. So it's not directly accessible for you. And it's also not configurable, so you can't change that 7 days to be something different. Yeah, so you need to request Snowflake support, and the failsafe is available only for a permanent table. So if you want to omit and don't have a failsafe, please use the transient tables. And you can also see how much data you have in the failsafe in the usage view under the admin tab. So there you can see how much data you will have inside the failsafe, so you can calculate the costs related to that. So here we have the overall life cycle, current data, time travel up to 90 days. You can access the data on your own with that at and before keywords. And finally, we have the failsafe with additional 7 days. So the cost optimizations I've mentioned already during today. Try to use the transient tables for the lower environments and intermediate tables, because then you don't have that failsafe period. You should also try to limit the time travel with transient tables. It's quite easy because the maximum value is 1 day and there is no failsafe. Yeah, monitor your fail spendings and cost management. And that's all. A few questions again related to the data protection for you. So feel free to read them and we will check the answers. Okay, let's have a look. What is the maximum data retention for time travel? And it's 90 days. Perfect. Let's move on. How we can configure the retention period for failsafe. Let's check. And yeah, the 7 days, it's correct, but it's not configurable, so you can't configure it. It's by default 7 days and it can't be changed. So the correct answer here is it's not configurable. How is called the parameter controlling the time travel retention period? Let's see. And it's called data retention time in days. Perfect. Let's move on to another topic, which is replication and failover. Replication and failover is another feature inside Snowflake. We have 2 types, database and account replication. And again, it depends on the Snowflake edition you have. Database replication is available on standard edition and higher. And if you want to do account replication, meaning you want to replicate also some account level objects, you need at least business critical edition. By account level objects, I mean users, roles, and warehouses. So those are account level objects. If you want to do a replication between accounts, all the accounts must be part of the same organization. So you can't do like you do a data sharing between various Snowflake accounts. You know, it must be within the same organizations. All regions and clouds are supported, so you can do a cross-cloud, cross-region replication. So you can replicate AWS region into Azure region. And for replication or failover, you create replication or failover groups. So inside that group, you put the objects you want to replicate or you want to do a failover for. And the setup for it is quite complex. And again, not everything can be replicated or not everything can be part of the failover group. So again, once you will be working on that, I would recommend to check a documentation, because you will find details related to every object if it can be part of replication or failover. So what are the other terms related to replication? We have a primary database. Inside the primary database, we have read and write possibilities. It's the main account where all the operations are. And then we have a secondary database, which is read-only. That's the target of the replication once we do replication of the primary database. So it can be in same or different region. And as I said, it can be also in the same or different cloud provider. Yeah, here we have a future metrics, what can be done on which edition. So on the standard one, what you can do is database replication, share replication, and you can create a replication group. Same goes for enterprise. And if you want to do a failover or account object replication, you need at least a business critical edition. Yeah, so here we have a schema showing how it can look like. We have an organization with account A and then account B, which will be the secondary one. And we want to replicate the database C. So inside the primary account, the database C has both read and write. And the same database is read-only in the secondary account. As I said, not everything can be replicated. For instance, external tables, hybrid tables, or iceberg tables. But the list what can and can't be replicated is changing over time. So I always recommend to check it with docs once you work on that. Yeah, if you will decide to replicate from higher edition to lower edition, like from business critical to enterprise or standard, it can cause some errors because yeah, you might have something on the business critical which is not supported on the lower editions. Yeah, here it goes. If you will decide to replicate some objects, so something can't be replicated, like if you will replicate the Snowpipes, for instance, the notification integration for Snowpipes are not integrated. What are the constraints? You can put database and shares into the single group only. If you will add it into multiple groups, it can be done, but you need to replicate each group to different account. And if you have both replication and failover group, you can't include the same object into both groups. So it needs to be either in failover or only in the replication group. On the account object, so only the one replication group can contain other objects than database and shares. How it works cross-region. This is related also to data sharing. So if you want to do something, the data sharing cross-region, first you need to do a replication into that region. Once the data are replicated there, you can configure a data share. Failover, business critical edition, and basically the difference between failover and replication is that the failover group and failover account can be promoted as a primary account once there is some disturbance in the primary account, so you can continue with your operations in that failover account. If the replication is currently running, the secondary replica can't be promoted to be a primary one. So you have a couple of options. You can wait until the replication is over, or you can suspend the future refresh operations and cancel the current running refresh, but it will cause some data inconsistency. So the best is always wait until it's finished, and then you can do the promotion. few more questions. Let's see. And for database replication, you need a standard edition. Yeah, it's available from standard. Another question. Let's see. And the correct answer is true. So data replication can be done to another Snowflake account, no matter what's the regional, the cloud provider. And the last topic for today is data sharing in Snowflake. So let's start with some general introduction into Snowflake. Basically, the data sharing is powered by something what is called SnowGrid, which is a Snowflake unique technology which connects different clouds and regions together. And thanks to that, you can change the data between the clouds and between the providers to maintain the global business continuity. You can share data across with no data movements, with no additional ETLs, and no data silos, so you can share the real data. But apart from the data, you can also share the logic and the services. And all of that works inside Snowflake, so you still have that governance control, which is available in single account. It's also available across the accounts. So let's try to compare secure data sharing in Snowflake with some traditional methods of sharing the data. So if you don't have a data sharing and you need to share data with some partners or customers, so what you can do, you have options like APIs, FTP, emails, additional ETLs and cloud storages, but you basically need to copy and move the data between different locations. Data will be delayed because you need to extract them, load them somewhere, and transfer them. It will be probably costly to manage and maintain everything because you need to ensure security on different layers. And it might be also unsecure because you need to move data out of one system, load it into different system. So pipeline can break, so it's error prone, takes time. Snowflake tries to mitigate all of that with their secure data sharing, meaning that there is like single copy of the data, so you don't have to copy data, no data delays, you are not moving it, no external ingestion, so no other data silos. And it's still privacy compliant because you still have your airbag control over the data shares. And you can revoke the access or grant the access quite easily. So there are different offerings related to data sharing. One of the data sharing offering is data marketplace. Data marketplace is a way how you can monetize your data. So you can basically prepare some data products and make them available in the marketplace, publicly available. There is a live access to the data. Again, the data are available cross cloud. you can offer it either for free or as a as a paid resource. For the data marketplace, we have like two key terms. They are data providers who publish the data set, and then they are data consumers who can browse through the marketplace and buy and consume the data. And yeah, data set can be free or paid. So how the marketplace look like? You can access it directly through Snowsite. It looks completely the same like the marketplace on your phone with the apps. So there are different categories, some filters. You can search through offered data products. And yeah, the data providers guarantee that the access to data is up to date and live. So you always consume the live data. You don't need to do any data refresh or something like that. The data are up to date automatically. So yeah, no additional ETLs. You just click buy or add the data, and it will be added into your Snowflake account as another database. So what are the core concepts related to the data marketplace? It's a data product. Data product is some kind of curated collection of different objects. It could be tables, it could be views, it could be UDFs. So all of that can be offered at the marketplace. And then we have a listing. Listing is basically the page of the data product where you can find the additional details and all the metadata related to that. So what the data set is about, how to use it, what are some typical queries you can use. We have several types of listings. It can be free, it can be monetized, and it can be also personalized. So if it's personalized, then consumer first needs to request to get access to it, and then you as a provider will grant the access, and you may also personalize it. So what we already know and we heard somewhere else is that we have providers, we have consumers, data share, data marketplace offerings is just data sharing offering, just bundled into some nice UI, but public data share. Inside the listing, I mean, on the page of the data product, you will find also a list of available regions where the data product is available. Data exchange. Data exchange is a different type of data sharing offering. It's something what we can call private data marketplace. So let's say that you want to cooperate with your partners or customers, but you don't want to share the data publicly. So you can create something, what is the data exchange, and then you can invite the other parties to cooperate with you. So you can grant who will be able to publish data sets on the data exchange, and you can also invite the consumers. So it can also work internally, so you can exchange data between different business units, or you can collaborate with external parties. Membership is managed, and we have different roles. So there is a data exchange admin who controls everything, and then we have data providers who provide the data, data consumers who can consume the data. Listings is the same. Reader accounts can't be part of the data exchange. So here we have a schema, how it can looks like. So you can see that we have multiple Snowflake accounts. This is our organization. There could be some customer organizations. And in the middle, we have then our private data exchange. So once the access is granted, also the other parties can either add some listing there or get the access to the listings which are published there. Direct data sharing, that's the last part, but I would skip that in order to provide the final summary, because we are running out of time. So that's just a few slides which you can go through it. It provides just some details how to do a direct data sharing, but I believe that some summary would be more beneficial for you. We can also share some tips and tricks for taking the exam. So let's go through that. And basically what we have covered during today and yesterday, we covered the basic stuff related to the Snowflake in terms of architecture, in terms of security, how those things works, how the data governance works in Snowflake, what are some data protection features. We covered some performance concepts, what you can do to do some performance tuning, I mean the basic stuff. We covered the compute layer in terms of creating the warehouses, maintaining the warehouses, and the scaling, how to work with caches, what are the different types of caches, protection, and also the data sharing types right now, like data marketplace, private data exchange, and direct data share. So I hope that you enjoyed the course and you learned something new what will help you with your Snowflake journeys, no matter what, if you are preparing for SnowPro core exam or if you are just starting your Snowflake career. If you would like to stay in touch, you can find me on LinkedIn, where I'm regularly sharing tips and tricks from Snowflake world. Here you have a link. You can also find me on Medium, where I'm also trying to share some more detailed stuff related to Snowflake. And if you enjoyed the course and you would like to get more Snowflake related knowledge, I'm running also other courses here at O'Reilly. So at the end of the month, there will be a data engineering bootcamp, which is full of data engineering stuff, and it's more related to data engineering certification. But I also run administration bootcamp or optimizing Snowflake, which is a little bit more advanced, and it's completely related to optimizing performance in Snowflake. I believe both of them, administration and optimizing Snowflake, will be live, or I will be running them during March. And if you are preparing for SnowPro Core, I also have a video course here at O'Reilly available, so you can also check that one. Even though the content is pretty similar, so it probably doesn't make sense to go through the videos again, only if you want to hear something again. But this course also contains 65 questions, which are in that style, which you can expect at the final exam. So if you want to get some practical tests and verify your knowledge, you can find some questions in this video course. So feel free to check that one. And let me share also some tips and tricks related to exam. This is, the core, SnowPro Core is like entry-level exam. So if you would compare it with the advanced one, this one is less practical and more theoretical. So it's trying to verify that you know and understand all the features and the architecture concepts rather than how to use them. So you can expect questions like, what is this feature for? How the what are the benefits of that feature? What can you do with that feature? And the questions are rather small and focused on really theoretical knowledge related to various features or architecture principles. How to prepare for the exam? What I would definitely recommend is going through the study guide. You can find the study guide on the certification page. The study guide contains all the topics which you need to know for passing the exam. And apart from the topics, it also contains links to the documentation. So you can directly from the study guide go into documentation and read the details related to that topic. The Snowflake documentation is really great. So I would really recommend to use it as a reference. When I am preparing for the certification, it's the only resource I use. So I would also recommend to have some hands-on experience with Snowflake. It's much better than trying to go and get the exam just by reading all the documentation and trying to get the theoretical knowledge. If you don't have like the project, Snowflake project, where you would be currently working on. You can also try to do some quick starts, which Snowflake offers, or try to check these level up tracks, because those are hands-on exercises and it will help you understand all the concepts better. So it's much better to have some real hands-on experience than doing it just purely with your theoretical knowledge. Of course, many people also want to validate their knowledge before they are going for the final exam. Yeah, there are plenty of courses available around the web, so feel free to try them, check them, but use them wisely, because the quality of them can vary. Not all the question dumps which you can find are relevant, or I would say I've seen questions which were not correct at all. So just really read the experience of others and don't trust everything what you can find on web. That would be all from my end. Thanks a lot again for your time and participating in this course. If you will go for SnowPro Core exam and you will pass it, feel free to share it with me. I will be more than happy to cheer for you. And I will also ask you to provide the feedback for this course, because it can help me to improve the course for next iterations. So if you can spare a few more minutes and fill the questionnaire about your experience, please let me know what you liked, what was good, what was not so good, what you would like to improve, so I can know what I can do next time better. And that would be the last thing from me. Thanks again, and see you soon at another occasion.
All right. Thank you, Thomas. Thank you for a fantastic day two today, and thank you for yesterday too, day one. And thank you, folks, for attending yesterday and today. We hope you've benefited from it, and we look forward to seeing you at another O'Reilly live courses. Now, you heard Thomas mention about the class feedback. So at the top right corner of your screen, you'll see the More button. Click on that and let us know your thoughts about the course. If you don't see that, not to worry. As soon as we end the course, you will see a pop-up appearing on your screen, and then you can let us know your thoughts about the course. The recording will be ready in about 24 to 48 hours after we end. You will receive an email with the recording link as soon as it is available. All right, with that, we will conclude today's session. Thank you and goodbye, everyone. Have a wonderful day, and for some wonderful night. Be safe and stay well. Thank you all.